And sorry, waiting. Okay, cool. All right, so here's the deal. You guys all have a data table that looks something like this. If you're missing some of this information and you need help, then let me know. You've got a week and a day to get it. But so ideally, you should have this filled in. All right, now, what we want to do is we want to create a graph that sort of summarizes what this data table is telling us, and then another one that summarizes what this data table is telling us. All right? I'll leave it to you guys to kind of futz with your formatting of this. Eventually, what we're going to do is we're just going to, once we've got this graph, this table formatted, we're going to literally just copy it. So I'm just going to do Control-C, and then paste it into my lab. Here's our data, blah, 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 blah. Oops, and then just do, yeah, paste it in, right? Okay, and so like looking at this, I notice, oh, it's a little bit sort of narrow. I didn't use the whole page. So, you know, you can embiggen stuff, whatever. Okay, so anyway, that's not why we're here. So what we need to learn how to do is how to take this information and make a graph. All right? So here is what we're going to do. In part 1 of the lab, what we did, if you don't remember, was we kept changing the hanging mass, but we kept the total mass constant. Okay? And the result of that was that as the hanging mass got bigger, so did the accelerating force, right? There was sort of more force pulling the whole system forward. And the result was we got both a bigger predicted and a bigger actual acceleration, right? So we want a graph that shows that. All right? So what is the independent variable? What's the thing that you were changing? The hanging mass, which what we really care about then is the force that that hanging mass applies, right? Yep. So our x-axis is going to be the accelerating force. All right? And then the y-axis is going to be the acceleration. Okay, so here's what I want you to do. And I just discovered this last hour working through this. The first thing you want to do is click the row or column that's going to represent your x-axis. So for us, that's going to be the accelerating force. So click accelerating force. See how I clicked the 4 over here? That highlights that whole row. That's going to become my x-axis. All right? Now, anything that you want to graph on your y-axis, what we're going to do is I'm going to hold down the control button. What that does is it tells the computer, hey, I want to select some more stuff. All right? And I'm going to click the other 2 things that I want to graph. So on my y-axis, I want to graph predicted acceleration and experimental acceleration, all while holding down the control button. All right? If you didn't do it in the right order, it's not going to work. So you got to do accelerating force first, then the 2 acceleration rows. Is everybody good up to there? All right. So now what I want to do is I need to tell the computer that I want to make a graph. For whatever reason, Google calls it a chart, which I don't really care for, but it is what it is. All right. So up here, there's a little drawing of a graph. Click it. Well, yay for Spanish. All right. So I clicked on that little drawing, and it gave me this chart editor. Don't do anything yet. Does everybody have a graph that looks like this? It's a great big mess. Yes. All right. While it looks very pretty, it doesn't tell us anything that we want to know. All right. So here's what we're going to do. The first thing we want to do is we want to tell the computer what kind of graph we want. All right. I will tell you that in all of my years, both teaching and taking science, I've never used anything other than scatter. Now, if you're going into, like if you took psychology and started doing like surveys and stuff, you might use a pie graph maybe. Or maybe if you were taking surveys, you might use a bar graph. But in science, we, at least as far as I've seen, I've always used scatter. All right? What a scatter graph does is this. It just plots x and y points. Right? Every data point gives me an x and a y coordinate. So that's what we're going to do, all right? So over here are the different types of graphs. See how it says line, area, da, 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 da. If you scroll down, you'll find, there it is, scatter. Click it. Boom. All right? With that what?
I got it.
Okay. Oh, I got this Spanish, right. Okay. We got to figure out how to fix that. All right. So it still doesn't look right, does it? All right. Now, I will tell you, the day that we did this first, I had never used Google Sheets to make a graph. I always use Microsoft, which is a little user-friendlier, but there's a lot going on. So anyway, I literally just monkeyed with this. I sort of did trial and error until the graph looked the way that I wanted it to. I will tell you what I figured out, all right? So because we're looking at rows, for whatever, and I wish that Google did a better job explaining sort of what these things mean. but they don't. So anyway, so here's what you want to do. We want to combine our ranges vertically. Okay, we're getting warmer. All right. Now, the issue is because we're graphing rows instead of columns, usually when you make a data table, you've got your stuff organized in columns. This time we've got it in rows. So I'm going to switch rows and columns. Oh. Switch rows and columns. See it right here? Switch rows and columns. All right. So if your graph doesn't look like this right now and you don't know why, raise your hand. All right. Hold on. All right. So here's the other thing I've found. For whatever reason, it's a little finicky. Freakishly, with you guys, this only happened once. Last hour, it happened with like 5 people, where their graph didn't look like this, and then we X'd it out and did it again, and then it worked. Totally random. So I don't know if they did something funky the first time or what, but that's the deal. Leah, are you good back there? You sure? Ian, are you good? Yep. Okay. All right, so now the other thing I would do is if I click this use column A as headers, it will sort of know what the values mean, right? So because column A has my titles here, so I'm going to click that, and then this use row 4 as labels will make things easier later on. So click that, and you probably didn't notice any change, and that's fine. All right, so is everybody good up to there? All right, so the next thing we need to do is we need to customize this, right? Because like we've got these points here, but sort of what happens between the points? So now I will say, if we had picked a line graph, what it would have done is it would have drawn a line between each of these points, and you get this jaggedy graph. All right, but that's not what we want. What we want to do is, instead of just connecting the dots, we want a best fit. In this case, it's going to be a line. In general, you want a best fit curve. This one happens to be a line. All right, so what I'm going to do here is I'm going to go to customization. Bam, right there. All right? So let's kind of run through here. Let's see. First of all, title. Oh, I should probably give this thing a title. Now, when you give a graph a title, it needs to be descriptive. Don't just put accelerating force versus acceleration. All right? So what are we graphing here? We're finding the acceleration of a 2 kilogram mass. Yes, it is a long title because it's going to tell us exactly what the graph is showing us. All right, so notice, one of the things you'll notice is that my total mass, well, let me move it. You guys can kind of see over here, the total mass of the system was always 2 kilograms, right? That's important, right? Because it means that more force is going to get us more acceleration, right? So this is acceleration of a 2 kilogram mass as a function of accelerating force or applied force, or however you want to write that. Why can't I type? And hit enter. All right, and there's your title. All right, now, your title will probably be exactly this since we just did this together. But for future reference, it needs to be descriptive, okay? Don't just say, force versus acceleration. Tell me more. Cool? All right, now, the legend, that means this little thing here. All right, I don't care where you put it. For whatever reason, I have a preference that I like to put it up at the top. I really don't care. Put it wherever you want, really, okay? But I like it there. All right. So there's other things you can do. You can change your font, whatever. Doesn't matter, whatever you like. Comic Sans, everybody loves that, right?
Thank you.
All right. So whatever. Pick some fonts that you like.
Yes.
All right. Now. Let's not. I shouldn't have even brought that up. Don't spend time with your fonts now. Do that later when we're not tight on time. All right, axes. Now, the axes need a few things. First of all, we need to label the axes so that whoever's looking at this graph knows what these numbers down here mean. Now, our horizontal axis was the accelerating force, so I'm going to call it that. And what else should I put? Units. Newtons. All right? So that's the title. All right, if for some reason you didn't like the fact that this is going from 0 to 1, you could change that and make it go from 0 to 5 or 0 to, whatever. You can change your max and your min. Now, grid lines. The grid lines are these up and down lines and side to side lines that sort of, make the graph paper. Does that make sense?
Yeah.
You could leave it like this. I like to have more because like this to me is like, well, where is that first red dot? Like it's sort of before 0.250, but I don't know where. So right now there are 5 major grid lines. So this 5 here is telling you the number of major grid lines there are. And there are 5 because there's 1, 2, 3, 4, 5 major grid lines, right? I'm going to change the color of them to make them a little darker. All right, and then you can do minor grid lines. Those will be the ones between the numbers. So since each of these is 0.25, let's put 5 in between there. Oh, look how pretty. Cool. And in a minute, we'll go back and we'll do the horizontal ones. All right, let's see. Number format is fine. Scale, default. All right, very good. All right, so now let's go up and change our horizontal one. So up here where it says axis, change it from horizontal to vertical. Now we can format a vertical axis. What are we measuring on the vertical axis, you guys? Acceleration. Give the name of it. And then the units, meters per second per second. Unfortunately, Google doesn't let you do superscript, so you just got to do meters per second, or you can do MS and put it to and whatever. All right, again, you can change your max and your min. I'm going to change my grid lines. Make those bold. Let's see, these are going up by 0.15. So if I put 3 in between, oh, look how pretty my graph is.
I am falling behind.
Oh, thank you for saying that. I don't mean that snarky. Thank you for telling me you're falling behind. All right, go. All right, so the next thing we need to do, you guys, is we need to figure out how to put in, we don't want to connect the dots. We want a best fit curve, right? Now, looking at these points, it looks to me like that best fit curve is actually going to be a nice straight line, right? Okay, so I'm still under customization. I'm going to scroll down some more. All right, and see here where it says series? So right now it's predicted acceleration, so that's the blue series, or I could choose the red one. Let's do the blue one first. Okay, if you already changed it, it doesn't really matter. If you want, you can change, the shape of the points from circles to triangles or diamonds or stars or whatever you like. It doesn't matter. You can make them bigger or smaller by changing point size, all that kind of stuff. All right, this thing we want down here, and I need you all listening for this part because this is the part that's a little confusing. At the very bottom, it says trend line. Right now, it's set to none. I'm going to click it, and I'm going to pick linear. Bam! Holy cats, look at that. Now, when you do that, when you turn that on, it gives you more options below. Label. I want to label that trend line. So instead of clicking custom, I'm going to click down, and I'm going to go to use equation. Holy cats, it gives me the equation for that trend line.
Whoa.
Right? Okay, so now I'm going to go back up, and I'm going to do the same thing with the other data series. So that was predicted. Let's go to experimental. Boom, experimental acceleration. Scroll down, trend line. It still looks like it's linear. Boom. Let's see, label, show equation. All right, and then the one other thing that I'm going to do, and this is just specific to me because I put my my legend up here at the top. Not everything's fitting. See how it's giving me this little arrow?
Yeah.
But the problem is when you print it, the user can't sort of click these arrows, right? So what I'm going to do is I'm going to take that legend. So somewhere up here, there's a box that says legend. No. Was there a movie called? Never mind. I shouldn't distract you.
I am legend.
There you go. That's what I'm thinking of. Okay, legend. Here we go. So I've got the legend at the top, but it doesn't fit. So I'm going to just change the font size. Let's see. How about 8? Oh, that almost fits. See how it almost fits here? But the problem is the words predicted acceleration and experimental acceleration are sort of taking up too much room. So I'm going to click insert, and it gives me my graph. Did I lose anybody there?
Yeah.
All right, here. So So I was here. I was here.
Yeah.
All I did was I looked at legend and I just made my font smaller.
Okay.
All right?
Mr. Eckert.
Yep.
Okay, so my red line is not going to 0. Does that matter?
Oh, I gotcha. No, that is totally okay. Yes, I'm glad you just said that. Fred just pointed out that his red line doesn't go through 0. Does it go? Is it up here or down here? Good. Down here is better.
No, don't do this. Okay.
Our line's like cross.
That's okay if your line's crossed. It's okay. Yeah. Hey guys, my data here, I made it up. So I sort of picked numbers that were going to look the way that it was sort of supposed to look. If yours doesn't look perfect, that's fine. And I'll be honest, having this line go through 0 is not probably accurate. I probably should have made it so that it crossed down here somewhere. All right. So anyway, do you guys see what I'm saying though here? How this stuff here kind of doesn't fit. So all I'm going to do is I'm going to just change the names of those rows so that it fits. Experimental, that can be abbreviated. Experimental acceleration. Boom. And then down here, predicted acceleration. Let's see, PRE, I can predict, or I can abbreviate that PRED. Then I can make this acceleration.
Wait, so after you hit insert and then you can fix it.
Yeah, and then you can edit stuff, exactly.
So did you already hit insert?
Yes.
Thanks, Joe.
Oh, why didn't it change my, I do. Oh, I see.
What did you experiment?
All right. There we go. Okay, so now, you guys can monkey around with it, but that's kind of the idea. You know, get it, play with it until it sort of looks nice, and now I've got this graph that I think looks quite nice. All right, so once you're done, you can just literally do Control-C, and then go into your Google Doc. You know, here's my graphs, and then paste it in. And, you know, make it an appropriate size, whatever.
Wait a minute, mine didn't like reset.
Experiment.
It didn't change predicted acceleration.
Okay, I'll have to look at it in a minute, because we only have a couple minutes here. So, all right, so you guys, the other thing, we're going to have some work time this week, so, you know, maybe instead of using time to work on your homework, you work on your lab, if you need to. All right, so are we at least okay up to here? Is everybody at like a 4 out of 5 in terms of understanding?
Yeah.
All right, cool. Now, very, very important. We're going to do kind of the same thing for part 2, with a very important difference. All right, so I need everybody's attention again. Are we okay? Griffin, you okay?
You have to hit Control C and then Control V.
Control C.
Then Control V.
All right, we'll get there, Marge. As long as you've got, hey guys, don't worry about copying it into the Google Sheet yet. We got to move on, or we're going to run out of time. All right, so. I just said Margaret, are you good?
What did you just
Sorry.
March.
Sorry, I have somebody in my other hour that goes by that. Okay, so
March.
part 2. In part 2, it's not the accelerating force that's changing, right? If you look at part 2, your accelerating force was fixed. What did we change? The cart mass, and therefore the total mass that was being accelerated, right? Okay, so this time my x-axis is not going to be the accelerating force, it's going to be the total mass of the system. All right? Now, please hear me say this. It's really important that you focus here while we do this last one. All right, so this time I'm going to click my x-axis, total mass of system, and then again the 2 accelerations, predicted and experimental. Good. I'm going to click on the little chart again, and then I'm going to follow the same process I did before. I'm going to combine my range vertically. I'm going to switch my rows and columns. Oh, no, I forgot to make it scatter. Darn it. Yeah, sorry, it's literally the same thing. So, scatter, vertically, switch rows and columns. Good. All right. Now, what do you notice?
It's a curve.
It's a curve this time. All right? Now, here's the equation, you guys. Check it out. This is this. Acceleration is net force over mass. We've got acceleration as net force over mass, but our net force is fixed. In math, this would be the equation y equals k over x. So when you graph it, it's an inverse function. All right, now, well, I know Google doesn't, and as far as I know, Microsoft, unfortunately, doesn't give you a best fit option for an inverse function. All right, so you theoretically you could try polynomial or you could try exponential. Exponential gives you something relatively close, but it's not correct. So, please hear me say this. This is your graph. I mean, put in your axes and stuff, but you're not going to do a best fit for this one. All right? You're going to do this, format it, make it all nice, and then you're going to print it up, and then you're going to find a red pen, and you're going to draw in your best fit curve. You're going to literally draw it in with your hand, and then find a blue pen and draw in your best fit curve. Like that, and you will not know the equation for it. Okay?
This is like some artist did.
Does that make sense?
And with the dumb art, it's like a bad art. Like an artist that was teaching.
All right, Sebo, are you good with this?
Can we?
No, but I'll figure it out.
Okay.
Could we use the computer for a curve?
Yeah, I mean, there is exponential right there.
But it's not exponential. If you use exponential, it'll hit the y-axis, and this will not. Okay? Yes. Okay. If you've got little specific issues, we'll either in the next couple minutes here or whatever. But so does everybody kind of understand the big ideas that I said there?
Yeah.
All right. This is all recorded, and you can check it on my website. If you go to today's date, go to the calendar. It's all there. All right. And we'll have time this week to work. All right. Good.